To continue with this example and make things as geometrically clear as possible, again, we have f of x, the original function, is 1 on x, and we found that f prime of x, what you might call, again, the slope function for this curve, was negative 1 on x squared. If I attempt to graph both of these simultaneously, so the original 1 on x, let's see here, how do I want to do this? We'll do 1 here, and 2 and 3, and 1 and 2. Okay, so on 1 on x, of course, you plug in the number 1, you'll get 1 out. If you plug in 2, you'll get out a half, which I guess would be about here. Plug in 3, you'll get a third. So maybe right about there, something like that. And we know that it has a vertical asymptote here. Draw that in very quickly. Okay, I hope that's visible. And we should have something like this. Also has a horizontal asymptote that's approaching there. That's its right in behavior. Okay, so there's 1 on x. Now let's graph negative 1 on x squared. So negative 1 on x squared is negative 1, negative 2. All right, so when you put in the number 1, you're going to get negative 1. When you put in 2, you have negative 1/4. So it's a little bit closer. I'm actually erase the 2 just to give me a little bit of space here. So it's a little bit closer to 0. Here, 1/4 is a little bit exaggerated. Actually, hold on 1 second. Sorry. I'm not thinking clearly. I guess it should be right about there. That'd be better. Okay. And 3 is negative 1/9. Now it's really close. Now it's really close to the x-axis. Something like that. Okay. It has the same asymptotes as 1 on x, it turns out. So let me just draw this in here. So it gets a little bit closer to the x-axis here than the original function does from underneath the x-axis. And you're approaching that asymptote as you go out to the right. Okay, so this one is negative 1 on x squared, i.e. the derivative. And the one up here is the original 1 on x. Right? So now what's happening? Well, we know that, let's see here, f of 1 is 1. But what is f prime of 1? F prime of 1 is negative 1. Right? So therefore, f of 1 is right here. Right? That point. There's 1 f of 1. But correspondingly, you have a slope, right? And the slope of this curve is negative 1. So if I were to draw a negative 1 slope, right, something like this, there's a tangent line with pretty much a negative 1 slope. Not perfect, but pretty much, you can imagine, negative 1 slope there. That's exactly the same as this value, right, on the derivative function. This value here of negative 1 that the derivative produces is exactly the same as the slope of the tangent line at 1 for the original function. Okay? You could play the same game throughout. So if we had f of 2, right, f of 2 is a half. Right? We have it plotted right here. There it is. You can see the colors or not. Okay, I have my green color. But f prime of 2 is negative 1/4. Okay? So that would mean I should have a downward sloping tangent line that changes its rate of 1 to 4. Right? So won't be perfect, but kind of imagine. Right, 1 to 4 change there, almost. Okay. There's our tangent line, and its slope is negative 1 to 4. Right. Negative 1 there. So negative 1 to 4, but that's exactly the same as the height on the derivative curve, right? On the derivative here, the function height is negative 1/4, but that's exactly the same as the slope on the original curve, in this case, the location of 2. So that's the geometric connection, you might say, between the derivative function, right, as its own curve, that its heights are the same as the values of the slopes, not the heights, but the slopes on the original curve.